The growing list of firsts for perseverance, NASA's newest six-wheeled robot on the Martian surface, includes converting some of the red planet's thin carbon dioxide-rich atmosphere into oxygen. A toaster-sized gold box-shaped experimental instrument aboard Perseverance called the Mars Oxygen In Situ Resource Utilization Experiment (MOXIE) accomplished the task. MOXIE successfully demonstrated a solid oxide electrolysis technology for converting the Martian atmosphere to oxygen. The atmosphere on Mars is about 95% carbon dioxide. MOXIE's first oxygen run produced 5.4 grams of oxygen in an hour, equivalent to about 10 minutes worth of breathable oxygen for an astronaut. The power supply limits potential production to 12 grams per hour, about the same amount that a large tree would produce. While the technology demonstration is just getting started, it could pave the way for science fiction to become science fact, isolating and storing oxygen on Mars to help power rockets that could lift astronauts off the planet's surface. Such devices also might one day provide breathable air for astronauts themselves. MOXIE is an exploration technology investigation. This is a critical first step at converting carbon dioxide to oxygen on Mars. The scientists say that MOXIE has more work to do, but the results from this technology demonstration are full of promise as they move toward their goal of one day seeing humans on Mars. Oxygen isn't just the stuff we breathe. Rocket propellant depends on oxygen, and future explorers will depend on producing propellant on Mars to make the trip home. To burn its fuel, a rocket must have more oxygen by weight. To get 4 astronauts off the Martian surface on a future mission would require approximately 15,000 pounds of rocket fuel and 55,000 pounds of oxygen. In contrast, astronauts living and working on Mars would require far less oxygen to breathe. The astronauts who spend a year on the surface will maybe use 1 metric ton between them. Hauling 25 metric tons of oxygen from Earth to Mars would be an arduous task. Transporting a 1-ton oxygen converter, a larger, more powerful descendant of MOXIE that could produce those 25 tons, would be far more economical and practical. Mars atmosphere is 96% carbon dioxide. MOXIE works by separating oxygen atoms from carbon dioxide molecules, which are made up of 1 carbon atom and 2 oxygen atoms. A waste product, carbon monoxide, is emitted into the Martian atmosphere. The conversion process requires high levels of heat to reach a temperature of approximately 1470 degrees Fahrenheit. To accommodate this, the MOXIE unit is made with heat-tolerant materials. These include 3D printed nickel alloy parts which heat and cool the gases flowing through it, and a lightweight aerogel that helps hold in the heat. A thin gold coating on the outside of MOXIE reflects infrared heat, keeping it from radiating outward and potentially damaging other parts of Perseverance.